We are going to cover the fluid mechanics question of GATE 2023, which is being asked. Now here, first of all, we'll try to see the number of questions that were asked. So total, I think five questions were there of 2 marks, and one question is of 1 mark. So totally six questions were asked. Out of that, one question has already been discussed in the thermodynamic session. So I'll be covering here five questions of fluid mechanics, right? So 5 into 2, that is 10, and one question of 1 marks. So total 11 marks, basically what? Allotted to fluid mechanics this year. Right. Now here we'll be starting with our first question, as you can see. So what is the first question? This question is of basically MCQ and is of 1 mark, right? Air which is having a density, right, of 1.2 kilogram per meter cube. Kinematic viscosity they have given as 1.5 into 10 power minus 5 meters square per second. It is flowing over the flat plate, right? It is flowing over the flat plate with the velocity u infinity. And then what we have at certain location of the this plate, at this location and at this location from the leading edge, at a distance 15 mm, we have the wall shear stress which is being applied is what? Tau W, right? And at a distance 30 mm from the leading edge, we have tau W2 that we need to find the relationship in terms of tau W, right? So first of all, we must be knowing whether it is a laminar flow or turbulent flow, right? Without knowing that, we cannot decide whether how the shear stress, wall shear stress will vary with respect to X. This is a flat plate, right? So how the shear stress is varying at this location from the leading edge, that is what we need to check, right? Now here, before that, we need to find the Reynolds number. What is the Reynolds number we have? Reynolds number, we know that rho, what? V into characteristic length. What is the characteristic length? That characteristic length is nothing but the distance from the leading edge. So here I'm just calculating at 30 mm maximum distance so that I can know whether the flow is laminar or turbulent, right? So rho V x divided by mu. So we can write mu V into x divided by nu, right? Because kinematic viscosity, we know that mu by rho. So once again, velocity they have given as what? 2. That is the free stream or average velocity. And then what is the distance? We are calculating 30 mm, right? If you convert in meter, that will be 30 by 1000. And kinematic viscosity is what? 1.5 into 10 power minus 5. So here, if you just calculate 2 into 30 into 10 power 5 divided by 1000 divided by 1.5. So it is coming out to be as 4.
You are currently the only person in this conference.
Sir, it got disconnected, sir. Can you please check? Yes. Mhm. Yes. Thanks. Now here, yes. Now here you try to see what I'm saying. So we are discussing this particular problem. Sorry for the disruption. Now here, question number 19. Here, what we are discussing, the Blasius result, right? For that, suppose whatever the boundary layer thickness is there, delta, right? How the delta is varying? We know that according to Blasius result, it is varying 5 into x under root of Reynolds number, local Reynolds number. So it is directly proportional to what? X to the power 1 by 2. This is what the variation of boundary layer thickness, right? How the shear stress will vary? We know that according to for the Newtonian fluids, we can write mu into dou u by dou y at y equal to 0, right? So here there is a no velocity profile they have given. So by using the what order of magnitude analysis, this maximum value u du is there. We can write u infinity, and y we can write what delta, right? So if what you're understanding from here, if delta is what varying as x to the power 1 by 2, then how tau will vary? Wall shear stress will vary inversely proportional, right? As you keep on moving along the plate, if you march along the plate in the positive x direction, the wall shear stress will decrease, right? The wall shear stress will decrease. Now there is a practical reason also why wall shear stress will decrease. As you march along the plate, what will happen? More and more amount of fluid layer will be coming in contact with the flat plate, right? More and more amount of fluid layer will be coming in contact with the flat plate. What will happen? There is a large amount of momentum transfer will be happening between the what fluid layers or among the fluid layers. So what will happen? That much of resistance which is being felt by the lower fluid by the flat plate will not be there, right? So that's why the wall shear stress will decrease. Now coming to the question, as they have given the distance at x equal to 15 mm, right? Whatever the wall shear stress is there, we need to find what is the wall shear stress at a distance x is equal to what? 30 mm. And we know this relation. So tau w1 we can write by what? x1 by x2 to the power 1 by 2, right? So tau w2, what we can write? X1 is what? 15 mm by 30, 1 by 2 into what? Tau w. So what will be the shear stress, wall shear stress at a distance 30 mm? That will be tau w divided by root 2. So which option will be correct? So here option D will be correct, right? D will correct. So this is regarding the question number 19, that is the first question. Now moving on to the next question, that is question number 2. Here they have given the velocity field in a two-dimensional flow field. That means the whatever the happening in the third dimensional, that is in the z direction, we will not be considering, right? So here what is the velocity field they have given? The velocity field u component they have given as kx, right? If you just take the I coordinates, here we have u component, here you have v component, right? And whole phenomena is happening in this xy plane, right? That is what 2D flow field. And what is the y component? Y component is what? Minus of ky, where k is given as 2 per second. The coordinate x and y are in meter. The gravitational effects to be negligible. If the density of the fluid is what? 1000 kilogram per meter cube. If the pressure at the origin, right, 0 comma 0, they have given as 100 kilopascal. They are asking what is the pressure at location 2 comma 2 in kilopascal. So Whenever we want to connect any pressure field with the velocity field, only equation which is basically used, right? For most of the cases, in all the scenario, whether it is inside the boundary layer, outside the boundary layer, that one equation is what? Navier-Stokes equation, right? So by Navier-Stokes equation, what we can write? By Navier-Stokes equation, suppose we are applying the Navier-Stokes in x direction and y direction, and gravitational, that is a body force, we will not be considering, right? So minus of sorry, we can write rho into, now if you just write acceleration, see what is the Navier-Stokes equation? Net force is equal to mass into acceleration, right? That force will be pressure force, gravity force, viscous force, right? So here we will be writing here what? Ax. What we can write? Ax, we can write minus 1 upon rho p by rho x, right? So that is what we are considering, only pressure forces, right? Here if you just think of viscous forces, that will not be coming, right? Now here what we can write further? Dou p by dou x can be written as minus rho into ax. What is the acceleration in x direction? Can be written, it can be written as u into dou u by dou x plus v into dou u by dou y. Omega, that will be 0. That will be 0. Here this will be dou u by dou z, right? Omega, they already mentioned 2D flow field, so omega is already 0, right? Plus 0 k cap, so that is 0. So only we need to think of what? U, that is given as kx. Dou u by dou x is what? K minus ky. Dou u by dou y, there is no component of y, there is no variable y in u component, so that will be 0. Ax will be k x square, right? So this can be written as dou p by dou x, we can finally write minus rho into what? Kx square. Similarly, my different dou p by dou y can be written as minus rho into ay, that is dou p by dou y. But ay is what? Acceleration in the y direction, u into dou u by dou x plus v into dou v by dou y plus omega into dou v by dou z. Again, omega is 0. So what we can write? Ay. U is what? U they have given as kx, right? And what is the v component of velocity? V component of velocity is what? Minus ky. Minus ky. So u is what? Kx. V component is what? 0 minus ky. Dou v by dou y. What will be the dou v by dou y? That will be minus k. That will be minus k. Ky square, right? So here if you just write dou p by dou y, that will be, we can write what? Minus of rho. Ay will be what? K y square, right? So finally, total pressure, we know that if you just write from the mathematics, from maths, dou p by dou x into dx plus dou p by dou y into dy. So what we can write? Minus dou p by dou x is what? Just now we have calculated minus rho k x square minus rho k y square. Now we have to do integration from whatever the value is there, right? 0 comma 0, that pressure value is there, and we need to find the pressure at a point what? 2 comma 2, right? This value is 0, right? So what we can write? Pressure 2 comma 2, and what is the pressure they have given at a location at the origin? 100 kilopascal, right? That is not 0, 100 kilopascal. So 100 into 10 power 3. Now here if we do the integration, what we will be calculating? X value is what? From 0 to 2. Y value is what? 0 to 2, right? So here if you just do the calculation, minus rho k x cube by 3 0 to 2, right? So here pressure 2 comma 2 can be written as 100 into what? 10 power 3 minus rho is what? 1000. K is what? Already we know k value, that is 2 into what? 1 upon 3 x is x cube plus y cube. X cube is what? 8 plus 8. So if you just calculate what you will be getting, here a little confusion is there. Here, see, here that is k, not kx square, right? This will become k square x, right? This will become k square x. Similarly, this will become kx square. And here also that is not, because k and k will multiply, right? K and k will multiply, that will become k square once again, right? So here whole integration will change. So here that will be what? K square y, this will be k square, k square, k square, k square, x y square by 2. That will be 2 square. This will be what? What upon 2? 4 plus 4, right? So if you just calculate 1000 into 4 into 8 by 2, so that is what? 100 minus 16 into what? 1000. So that is what? Pascal. But we need to calculate pressure at 2 comma 2 in kilopascal. So that will become what? 84 kilopascal. Right. So this is what and how we need to calculate this particular question, right? So that is regarding question number 62. Now we need to move on to the next question. Now some of you might have confused. Some of you might be thinking, sir, here while writing the complete Navier-Stokes equation, there will be some viscous term will also be there, right? So I agree with you. If you just write complete Navier-Stokes equation, right? If you just write complete Navier-Stokes equation, so this will be Ax minus 1 upon rho, dou P by dou X plus mu by rho, dou square U by dou X square plus dou square U by what? Dou Y square. This thing will be there. Now some of you might be thinking that what will be this term, right? So just think of this. U we know that's right. So what will be dou U by dou X? That is K. What will be dou square U by dou X square? That is 0. What will be dou square U? Dou U by dou Y itself is 0. Then what about this? Automatically 0. So whole term will be 0, right? Similarly, in the Y direction, whatever the Navier-Stokes we have applied, Navier-Stokes in Y direction, whatever we have applied, here also whatever the viscous term will be there, right? Whatever the viscous term will be there, once again that will be 0, right? So don't think that we have neglected that, without calculations. If you calculate also, it will be 0, right? Because if you just write mu by rho, dou square V by dou X square plus dou square V by dou Y square, right? So this term will be coming. Now moving on to this question. Once again, it is a very easy one. If you just know the what general continuity equation. So already, if you just see this question, consider a unidirectional flow field. That means in a one direction the flow is happening. We are not bothering about the other directions, which is being given by the flow field U I cap, right? Where at a particular time t, at an instant of time t, at the basically what initial location, velocity is what 1 unit, and if the spatially homogeneous density field will vary with respect to t something by this, then we need to find what is the velocity at a location 2 and when the time is what 1. Now, so general continuity equation, if we just write dou by dou x of rho u, dou by dou y of what rho v, dou by dou z of what rho omega plus dou rho by dou t, so that will be 0. But here there is a no component in j direction, no component in k direction, so v will be 0, omega will be 0, so that will be 0, right? So what we can write, dou by dou x of rho u plus dou rho by dou t, we can write like this. Further, if we simplify this thing, rho into dou u by dou x plus Chan rule, right? So u into dou rho by dou x plus dou rho by dou t, that will be 0. So what we can further write, rho we know that 1 plus 0.2 e to the power minus t, right? And what is the value of what is the equation we are having? Rho into dou u by dou x plus u into dou rho by dou x plus dou rho by dou t, that is equal to 0. So here we can write there is a no term of x here in the density, so this will be 0. So here it will be 1 plus 0.2 e to the power minus t dou u by dou x. Dou rho by dou t will be what? Minus 0.2 into e to the power minus t from mathematics. That is once again 0. So here what will be the dou u by dou x? That will be 0.2 e to the power minus t. 1 plus 0.2 e to the power minus t. So here if you just do the integration of partial differentiation, so here if you remember, whenever you are doing the integration of what partial differentiation, that constant term will not be added, just like a direct full integration, right? Here we will be adding some function. Here the function, you know that u is a function of what? X and t. So definitely here if you do the integration, some function of t will be coming, because if you further differentiate, automatically this term will be 0, right? So here if I'm going to write u of x comma t, this whole term will be constant because we are integrating with respect to x only. So here what we can write, if you just do the integration, then I will add f of t into x plus f of t plus f of t. So at x equal to 0 and time equal to t, what they have given? They have given the value u is equal to 1, right? So put those values. E to the power what? At x equal to 0, so this whole term will be 0 plus f of t, right? So f of t will be what? F of t will be 1. So u of, we need to find x t, this can be written as 0.2 e to the power minus t, 1 plus 0.2 e to the power minus t, x plus 1. We need to find the value at 2 comma 1, right? 2 comma 1. So what will be the value? 0.2 e to the power minus 1, 1 plus 0.2 e to the power minus 1. Value of x is what? 2 plus 1. So what we can write? What we can write? If you just calculate, you will be getting 1.137. And in what we have to substitute? Round up to 2 decimal places. So the correct answer will be 1.14. This will be the correct answer, right? So moving on to the next question, which is once again very, very important. The figure show that two fluid system, which is held by the plate, and this plate is hinged at the bottom. Atmospheric pressure which is being acting, right, on both the sides. Of course, whatever the atmospheric pressure will be there, this will be acting here also. This will be acting here also. Whatever the PATM is there. So PATM movement will cancel out. So no need to calculate the movement because of the atmospheric pressure, right? The movement per unit width about the base of the hinge will be how much? In kilonewton meter per meter, right? So, and of course, we need to take the G value not as 9.81. We need to take it as what? 9.8 meter per second square, right? So here, first of all, we'll be making what? The diagram. This is the plate. So this question can be solved very easily by Prism method, right? I'm solving this method, this particular problem by Prism method, right? In that, we will be construct one prism, and with the help of prism, we will be calculating the total force, and then we'll be calculating where exactly this total force will be acting, right? Now, at a distance 1 meter, there is a density of the fluid is what? 1000 kilogram per meter cube, and we know that pressure will vary linearly for an incompressible fluid, but the density changes will not be happening. This will be linear one, right? The whatever the second fluid is there for this one, it may be like this, it may be like this, it may be like this, right? So it can be anything based on the density of the fluid, right? It is 2 times, so this will be something like this. So if you just construct, if you just make the, if you just construct the volume of the prism, it will be something like this, right? And now if you just think of the calculations, now it is very easy. So here, whatever the volume of the prism is there, first of all, you just calculate what is the force which are acting here. Then you calculate this particular force. Then you calculate this particular force. And we need to take the moment about this hinge point O, right? What is the force 1? The force 1 will directly give the value, this volume, this particular volume of the prism. Whatever the volume of the prism you are looking right now, just calculate the volume, right? They have given in the problem width as 1 unit. What they have given the width they have given as 1 unit, right? So if you just calculate the force exactly at A, let me take C, this will be what, D, C dash. Now what is the basically the pressure value at C? Rho 1 G into H1, where H1 is what, 1 meter, and H2 is what, if you just calculate the H2, that is nothing but 2 meter, right? So what is the force, what is the pressure value, what is the volume of the prism? AC D dash. What is the volume of the prism AC dash, right? So half of rho 1 G H1, half of rho 1 G H1 into what? Into what? Height H1. And exactly at what value it will be acting? It will be acting exactly at a distance what? If you just think of the distance, it will be here to here. This will be 1 upon 3 plus 2, because we need to take the distance from the hinge point, right? So what will be the value? The distance will be 1 upon 3 plus 2. This is very, very important, right? This is the total force. This is the force. This is the force F1, right? Into width, that will be multiplied. So width is what? 1 unit. They already mentioned in the problem. What is the per unit width we have to calculate, right? So that will be per unit width we are calculating. Now, some of you might not be believing that it is a kilonewton, right? Or whether this, if I just calculate the volume of the prism, will directly give me the force. Now, some of you might be thinking, sir, how? So I told you, right? Whatever the half is there, right? Half of base into height, right? We are writing base into height into width, right? So base is what? Pressure value, that is Newton per meter square, right? Height is what? Meter. Width is what? Meter. This will cancel out. So what is the unit of volume of the prism? Newton only. Don't think meter cube, right? We are calculating in terms of what? Pressure value, and that pressure value we are converting into volume of the prism. That's why I mentioned that prism method, right? Now, the second one will be calculation of what? Force F2. And how to calculate the force F2? This particular rectangular one, right? This is a 2. This is the first force. This is the third one, right? So this will be second one. What is the value? Rho 1 GH1. Base height is what? 2 meter. Height is what? 2 meter. And exactly at what distance it will be acting? Exactly at the center of the rectangular one, right? From here to here. From here to here. What will be the third one? Once again, third one will be very, very easy for third force. How to calculate that? That will be calculation of what? Rho 2 GH2, half of base into height. Height is what? H2. Half of rho 2 GH2. That much of pressure will be acting. Height into width is what? 1 unit. And exactly at what distance? H2 by 3, right? Now, my dear friend, we need to just think of the final calculation, that is the total moment about O, right? So what is the value? Half of rho 1, I am writing what? See, they have given 1000 kilogram per meter cube, but we need to calculate movement in terms of what? Kilonewton meter per meter, right? If you just think of unit, kilonewton meter, that is the moment per unit width, right? So it's better that you just write density as 1, because we are converting into kilonewton, Newton to kilonewton, right? 9.8 into what? Height, that is a 1, right? Into 1, 1 upon 3 plus 2 plus 1 into 9.8 into 2, not 9.81, 9.8 into 2. This one will be half of rho 2 is what? 2000, but I'm converting Newton to kilonewton. So rho 2 will become what? 2, 9.8 into 2 into 2 into 2 divided by 3. H2 is what? Remember, H2 is what? 2 meter, right? As I shown in the figure. If you just calculate overall, it will be coming as 57.166 kilonewton meter per meter. They are saying that round off to which particular decimal? One decimal. So the correct answer will be 57.2 kilonewton meter per meter. So this is a very basic Prism method that is already given in the Archibonsal also. You can follow that, and you can, if you just want to follow standard procedure, again in Sinjal also this particular method is given, right? So this is all about this particular question number 64, right? Now, already, why they have given the atmospheric pressure to confuse you? Because some of you might have done the blunder in drawing the figure. You might have drawn this figure, and you might have taken complete atmospheric pressure. Whatever the P atmosphere is there, 100 kilopascal, and if you just think of that, it will be acting exactly at the centroid, and I will be calculating half of 3 into half of 3 into P ATM into width. Once again, this will be acting exactly at 1.5. If you just add this 57 point something, this value 166, that will be completely wrong, because atmospheric pressure is not only acting from one side, it will be acting here also, because this plate is not being placed in a condition where atmospheric pressure is acting on from one side. How it is possible practically, right? Now moving on to the last question of this fluid mechanics session. Here, if you just think of an explosion at a time t equal to 0, releases the energy E at the origin in a space filled with the gas of density rho. Subsequently, a hemispherical blast wave propagates radially outwards as shown in the figure. Let R, that is denote the radius of front of the hemispherical blast wave. The radius R follows the relationship R is equal to what? They have given the relationship K, T to the power A, E to the power B, and rho to the power C. Without any thinking, if you just think of this format, it is nothing but dimensional analysis question directly. The value of the exponent A they are asking. So directly we can just equate the dimensions, radius, right? So m0 L T to the power 0, right? K, that is constant. Now what is the time? T to the power A. Energy is what? Force into distance. So that is nothing but mlt minus 2 into what? L. So this will be what? ml square into t to the power minus 2 b. Density will be what? Mass by volume. So this will become what? ml minus q, ml minus 3 to the power c. If you just compare the what respective mlt powers, you will be getting the answer. First of all, if you just do that, comparing the dimensions or equating the dimensions, on both the sides, if you just compare the m, so if you just compare the m for m, right? So that is 0 what? B plus C. That is the first equation. If you just compare the dimension of L, left hand side what we have? 1, that is equal to what? 2B minus 3C. If you just solve this one, equation number 2 and equation number 1, you will be getting B value, right? And if you just compare the T dimensions, whatever the T power is there, so that is what? We have 0, that is equal to minus 2B minus what? Plus A. So A will be 2 times of B. Just calculate B, put the value, you will be getting what? A. So here we can write 2B. Equation number 1, if I multiply by 2, I will be getting this thing. 2B minus 3C, that is equal to what? 1. If you just calculate, if you subtract equation number 1 multiply by 2 minus equation number 2, you will be getting what? C is equal to minus 1 upon 5. If you get C value, what is the B value? 1 upon 5. Once you get B value, what is the A value? 2 by 5, that is 0.4. And that is what they have framed. A very simple question. Only some of you might be thinking this question is from heat transfer. You might be calculating something like a MEC power and all. but don't think in that manner, because already they have given the format, right? So you need to just connect the dot between the what the question has been framed to the respective topics, right? So thank you all. We have discussed all the questions of fluid mechanics. One question is there regarding the compressible flow, that but that question is already being discussed in the thermodynamics session, right?
You are currently the only person in this conference.